Okay, so for this exercise, we're gonna hit upload in the left navigation menu, click browse, navigate to your TD2 folder, and then open up the Linear Regression notebook by clicking open. Now we'll begin by looking at a very simple linear regression model. This type of learning is supervised learning since it determines how the input variables temperature, humidity, and wind speed affect the output or response variable bike rentals. So first, you want to upload the corresponding data file in CSV format, that's comma separate values for short. You can do this by clicking on the folder icon in the left navigation menu. Click on the first icon that looks like a document with an arrow pointing up, and then open up the bikes CSV. Okay, so this warning box. If you're not doing an exercise in one sitting for any of the exercises inside this TD, make sure to upload the file every time you reconnect to the notebook, since it deletes every time the runtime is terminated. That's just what this warning box is telling us. So click OK. And then when you're finished with that, run the first cell under Collect the Data. This will import the pandas package and then import the data we just uploaded as bike CSV into the data frame that we named bikes using the assignment operator, which is just an equal sign. And by running the cell, which you can either hit this play button or Control Enter, it'll do the same thing. And this will show you what the data looks like. So each row is an example inside the data set, and then each column here, temperature, humidity, and wind speed, are the predictor variables for the data set, while the response variable is rentals. So rentals is dependent on the predictor variables. You can skip over the second section and explore the data since it's just a summary and statistics for that data, and we just won't be covering much statistical concepts in this TD, otherwise it'll just get too mathy. All you need to know is that linear regression models assume a linear relationship between predictors and response variables. Oh, but if you want to see a visualization of this relationship, you can just run this third cell and it'll plot a scatter plot for you with the predictive variable temperature and the response variable rentals. This shows a positive linear relationship between the two. So as temperature increases, so do rentals. And as temperature decreases, so do rentals as well. Also same with the next cell. This one shows a negative correlation or linear relationship between humidity and bike rentals. So as humidity increases, rentals decrease, and as humidity decreases, rentals increase. Humidity is the predictor and rentals are the response. This relationship is inversely related, and you can also run the following cell for wind speed and rentals and observe that relationship if you want to, but I'll just leave that one be since I think you get the point already. In section 3, we're going to define a dependent variable, in other words, the response variable, and then we're going to assign it to rentals. And then we're going to take all the responses from our dataset bikes and assign it to the data frame Y. In the next cell, we'll do the same thing but with X by listing the columns from our dataset and assigning it to predictors. Remember back to when we saw a preview of the data when we first ran the cell? Oh, hold on, I can just show you here. The columns were our predictor variables, so temperature, humidity, wind speed, and the rows were an example in the data set. Now before we train the model, we have to split up our data into two sets, one for training the model on and the other for testing the model on data, or in formal terms, examples it has never seen before. We do this by importing the train test split function into our code, which is from the sklearning package, and that's all this line is doing. In the second line, we're splitting the X data frames into an X training set, an X testing set, and then the Y data frame into a Y training set, and then a Y testing set. For this random state, It's just a hyperparameter in the train test split function that controls the shuffling process for splitting the data. The number assigned, 1, 2, 3, 4, is just to make sure that we get the same split every time the script is run. And this can be any number. It doesn't have to be 1, 2, 3, 4. It can be 42. Run it, and we get the same effect, since random state is just a constant. To build the linear regression model, we import the linear regression class from the same sub-package as sklearn under train the model. And then we'll use this function to train the model. In this cell, we're going to type model equals linear regression. So we're going to call on the function we just imported. And then we're going to fit it to the function and then pass the parameters xtrain and ytrain. Yep, okay, go ahead and run the cell. And then what we're trying to get here is an estimate of the intercept and the slope values for a regression line that best fits the data. So we do this by model.intercept and then run the cell. And referring to the intercepts in the model here, it'll let us know that the value for our regression line is 37, 39. Same thing with the slope or coefficient values in the next cell. So instead of intercept, you use coef. So model.coef. Run the cell. And then you may have already noticed that both of them printed out in an array format. So an array is just square brackets. And that's because when you have multiple attributes like our independent variables, so let's look back to our independent variables. Temperature, humidity, and wind speed are columns. It's going to correspond to the array here. Temperature, humidity, and wind speed. This array will list our values based on how those variables were listed in the training data in that particular order. In the next section, we're going to evaluate our linear regression model by calculating R-squared. If you can't remember back to stats class, R-squared is another name for coefficient of determination, which is a number we want to get close to as 1 as possible. It just means that our model would be better that way. So under evaluate the model, we're going to type model.score, and then we're going to pass along the parameters x-test and y-test. Go ahead and execute the cell. So first we put model.score, which is just a method in the model, and then we're going to give it the parameters x-test and y-test. Now to interpret the results, this number is the R-squared value, and it's just saying that our model is able to explain 98% of the variability in the response values according to the test data we fed it. We'll also evaluate how accurate our model is again in the next cell by comparing the predicted values to the actual values. These actual values come from the data split we did way back in the beginning of our exercise between training and testing. So we're going to type ypred equal to model.predict, and then we're going to pass along the x-test parameter. So the model's predicted response values for the test data using the model.predict that we used earlier, we pass x-test through it and then assign it to the variable ypred. Lastly, we're going to calculate the mean absolute error between actual response values and the predicted response values. So in this cell, we're going to type our imported function mean absolute error, and then we're going to pass along the parameters y-test and ypred, and then execute the cell. Okay. the results can be interpreted that our predictions will be off by about plus or minus 202 bikes from our model. So that's it for this exercise. Please take a screenshot of this last section and then paste it onto your answer sheet.